Good evening to all. I am MRS.K.DEVI, Department of Computer Science, A.D.M. College for Women, Autonomous, Nagapattinam. Now we are discuss about the topic operating system service, user operating system interface, system calls, types of system calls, operating system programs, operating system design and implementation, operating system structures, operating system debugging, operating system generation, system boot. First one, the operating system service. Operating system provide an environment of execution of program and service of program and users. One set of operating system service provide functions that are helpful to user. First one, the user interface. This means the UI. Almost all operating system have a user interface. Varies between command line, it means CLI, graphic user interface, it means the GUI, batch. First one, the program execution. The system must be able to load a program into memory and to run that program and execution either normally or abnormally. Input output operations. A running program may require input output which may involve a file or an input output device. One set of operating system service provide functions that are helpful to user. File system manipulation. The file system is one of the particular instances of program needed to read and write files and directories, create and delete them. Each them search to list of files information and permission management. Communication. Process may exchange the informations on the same computer or between the computer over the network. Communication may be via shared memory or through message passing. Packet moved from by the OS. Error detection. OS need to be constantly aware of possible errors may occur in CPU and memory hardware in input-output device in user program. For each type of errors, operating system should take the appropriate actions to ensure correct the consistent computing. Debugging facilities can greatly enhance the user and programmer's ability to efficiently use the system. Another set of operating functions existing for ensuring efficient operations of the system itself. Resource sharing. Resource allocation. When multiple users or multiple jobs running concurrently, resource must be allocated to each of them. Many types of operating system: CPU cycles, main memory, file storage, input-output device. Accounting. To keep track of which user use how much and what kind of computer resources. Second one, the protection and security. The owner of information stored in a multiple user or networked computer system may want to control use that information. Concurrent process should not interface with each other. Protection involve ensuring that all access to the system resource is controlled. Security of the system from outside requires user authentication. Extends to defending external input-output devices from invalid access attempts. The view of operating system service. The user and other system programs, the three types. First one is the GUI, batch and command line. Second level of the user interface. Third one is the system calls. The user operating system interface, it means a CLI. Command line interface or command line interpreter allows direct command entry, sometimes implement in kernel, sometimes by the system program. Sometimes a multiple flavor implemented the shell programming. Primarily fetch the command from the user and execute it. Sometimes the command built in, sometimes just name for the program. If the later adding new features does not require the self modification. User friendly. Desktop, the interface, usually the mouse, keyboard and monitor. Icons represent files, program and actions, etc. Various mouse buttons over the object in the interface causes the various actions invented at the Xerox. Many systems now include both CLI and GUI interface. The Microsoft Windows is the CUI with the CLI command shell. Apple Mac OS is the Aqua GUI interface with the Unix kernel for the shell available. Unix and Linux have the CLI with optional GUI interfaces. The touchscreen interfaces. The touchscreen devices require the new interfaces. Mouse does not possible or not desired. Actions and selections based on the gadget. Virtual keyboards for text entry. The voice command. System calls. The programming interface to the service provided by the operating system, typically written in high-level languages, it means the C or CPP. Most accessed by the programs via the high-level application program interface rather than direct system call use. Three most common APIs are the API Windows, for the API for the POSIX based system, including the virtual for all versions of Unix, Linux and Mac OS. Examples for system calls. The system call sequence to copy the content of one file to another file. The source file is the original text. The destination is the end of the source. System call implementation. Typically, the user number of associated with each system call. The system call interface maintain a table indexed according to these numbers. This system call interface invokes the intended system call in the operating system kernel and return status of the system call and any return values. The caller need know nothing but how the system call is implemented. Just need to obey the API and understand what OS will do as a result call. Most detail of operating system interface hidden from programmer by API. The API, the system call and the OS relationship. The user application is called by the system call interface. The system call parameter parsing. Often, more information is required than simply identity to desire the system call. Exact type and amount of information vary according to the operating system and call. Three general methods used to pass parameter to the operating system. The simplest. Pass the parameter in registers. Parameter stored in the block or table in memory and address of block passed as a parameter in a registers. Parameters placed or pushed onto the stack by the program and popped off the stack by the operating system. Block and stop method do not limit the number of length of parameters being passed. Parameter passing via the table. The types of system calls. The first one is the process control. It means the create process and terminate process, end and abort. Next one is load and execute the program. Get the process attitude and set process attitude. And next wait and time for the process. Wait event and signal event. Next the allocated and free memory. Next one the dump memory if errors. Debuggers for determining bugs and single steps executions. Logs for managing access to shared data between the process. Types of system calls. First one is the file management. Create file and delete file. Open and close file. Read and write and repositioning. Get and set file attributes. Device management. Request device and release device. Read and write repositions. Get device attributes, locally attached or detached the device. Information maintenance, get time or date, get system data, get and set the process or file. Communication, create delete communication connections, send and receive the message if message passing the model to the host name or the process name. Shared memory level, create again access to the memory region. Transfer the status the informations, attach and detach the remote service. Protection, control access to resource, get and set permissions, allow and deny the user access. Standard the C library examples. The C program invoking the printf library calls which calls write the system calls. Examples of MS-DOS. Single task, shell invoked when system is booted. Simple method to run program. No process created. Single memory space. Load program into the memory overwriting all but the kernel. FreeBSD. The first one is the Unix variant. Multitasking. User logging invoke the user choice of cell. Shall execute the system calls. Execute the files. Shall wait for process to terminate the commands. System programs. System programs provide the convenient environment for the program development and executions. They can be divided into file manipulation, status informations, programming language support, program loading and executions, communication, background service, application program. Most users view of the operation system is defined by the system program, not the actual system call. Provide a convenient environment for the program development and executions. File management, create, delete, copy, rename, print and list the general manipulate files and directories. Status informations. Some task the system for info, the data, date, time, amount of available memory and disk space and number of users. Other provide the detailed performance, logging and debugging informations. Typically, these program format and print the output to the retail of the other output devices. Some system implement the registries. System program, file modifications, text editor to create and modify the file, special command to search the content of files or perform transformation of the text. The program loading and execution, obsolete the loader, relocated the loader, linkage editors and overlay. The loader debugging the system for high level and machine language. Communication, provide the mechanism for creating the virtual connections among the process, user and computer system. System program, background service, launch and boot time, some for system startup, providing facilities like disk checking, process scheduling, error logging, printing. Run in user context, not kernel context, known as the service subsystems. Applications programs do not to the system run by the user, not typically considered the part of operating system. Designing and implementation of operating system not swallowable, but some approach have the proven successful. Internal structure of different operating system can vary widely. Start the design by defining the goal and specifications affected by the choice of hardware, the type of the system, the user goal and the system goal. The user goal operating system should be convenient to use, easy to learn, reliable, safe and fast. The important principles of the operating system design implementations. The mechanism determines how to do something, the policies decided what will done. The separation of policies from the mechanism is very important principles. Specifying and designing the operating system is high creative and task of the software engineering. The operating system structures. General purpose operating system is very large program. The various way to structure ones. Simple structure, more complex, layered and microkernel. The MS-DOS. The MS-DOS is written to provide the most functionality in the least space, not divided into modules. Although the MS-DOS has some structures in the interface and the level of functionality are not well separated. Non-simple structures. Unix limited by the hardware functionalities. The original Unix operating system had limited structuring. The Unix operating system consists of two separable parts, the system program, the kernel. The layered approach. The operating system is divided into the number of layers, each built on one top of the layer. The bottom layer is the hardware. The higher is the user interface. With the modularity layer are selected such that the each use functions and service of only lower level layers. Microkernel system. Much such as the sum of the kernel into the user space. Mark examples of the microkernel. The communication task placed between the user modules using the message passing. Benefits and demerits. Benefit. The easier to extend the microkernel. Easier to port the operating system to new architecture. The demerits. Performance overhead the user space to kernel space applications. Modules. Many modern operating systems implement the loadable kernel modules. Use object-oriented approach. Each core component is separate. Each is loadable and needed within the kernel. Example, the Linux, etc. Hybrid system. Most modern operating systems are actually not one pure model. Hybrid combines the multiple approaches to address performance. The Linux and the solarized kernel is the kernel address space to modularity of the plus dynamic loading of functionalities. iOS. Apple made OS for the iPhone, iPad. The structure on Mac OS added the functionality. Does not run operating system applications. Operating system debugging. The debugging is finding and fixing errors. Operating system generate the log files connecting error informations. Failure of an application can generate code dump files capturing the memory of the process. Operating system failures can generate crash dump files. Filing the periodic sampling the instructions pointers to look for the statistical trends. Performing the turning. Improve the performance by removing the bottleneck. Operating system must provide means the computing and displaying the measuring of operating system behaviors. Generation. The operating system are designed to run on any of the classes of machines. The system must configure the each specific the computer site. System boot. When power initialized on system, execution start at the fixed memory locations. Firmware ROM used to hold initial boot code. Operating system must be made available to hardware so the hardware can start it. Small piece of code bootstrap loader stored in the ROM or the EPROM located in the kernel. COM and bootstrap loader allow the selections of kernel from the multiple disk. The kernel loaded and the system in the then running. Thank you.